Yeah, hello everyone. Welcome you all to this session. So here in this session, we are going to discuss the AIET 6 class 11 JEE solutions for chemistry. Okay, so here we will discuss some important questions and the questions which you feel very difficult. Got it? So let's move on to the first question for this session. Question number 31 of your question paper. Yeah. So it states that the amount of oxygen in 3.6 moles of water is. So we have to find out the amount of oxygen in 3.6 moles of water. Okay. So let me go with this. So we all know that 1 mole of water has 16 gram of oxygen, right? Because the atomic mass of oxygen is 16 and for hydrogen it is 1. And since we have 2 hydrogen, it will be 1 into 2. So we will have 18 in total. So here the atomic mass of oxygen is 6. So 1 mole of H2O has 16 gram of oxygen. Now we are asked to find out the amount of oxygen in 3.6 moles of water. So the 3.6 moles of water has 3.6 into 16 gram of oxygen. Okay, it is equal to 57.6 gram of oxygen. Okay, so option B is the correct answer for this question. Okay, so let's move on to the next question. Question number 34. 1 mole of A and 1 mole of B are taken in a vessel and they react according to the reaction. 2A plus 3B giving 4C plus 5B. The ratio of the moles of C and D formed will be. So here A and B both are taken in equal amount, that is 1 mole and 1 mole. So no matter what the initial amounts of A and B are, the ratio of moles of C and D will always be formed in a 4:5 ratio only. Okay, so since we have 1 mole of A and 1 mole of B in a vessel, so we don't have to bother about the number of moles of A and B, the initial amount of A and B. So C and D, they are going to remain same with the 4:5 ratio. Okay, so option C will be the correct answer. Now coming to question number 35. How many grams of oxygen is required to burn 4 gram of methane gas completely? So here, let me write the combustion reaction of methane first. So CH4 is methane, and when methane reacts with 2 moles of oxygen, it produces 1 mole of carbon dioxide and 2 moles of water. So this is the complete combustion reaction of methane. Okay, and here the mass of CH4 is 16 gram. For carbon, the atomic mass is 12, and for hydrogen it is 1. So we have 4 hydrogen. So 4 into 1 is 4. The total amount of CH4 is 16 gram. And coming to oxygen, the atomic mass of single oxygen is 16 and we have to O2. So it will be 32 and 32 into 2 moles, right? So it will be 64. So 16 gram of methane is reacting with 64 gram of oxygen. Okay. Now, when 4 gram of methane, so here in the question we are asked to find out for 4 gram of methane, right? So 4 gram of methane reacts with how many grams of oxygen? So it will be 4 into 64 divided by 16. Just cross multiply and we will get 16 gram of oxygen. Okay. So 16 gram of oxygen will react with 4 gram of methane. So option A will be the correct answer for this question. Got it? And coming to question number 46, which of the following facts regarding the I3 minus ion is incorrect? So let me give the structure of I3 first. So it is linear in geometry. So 3 iodine molecule and the central iodine will have 3 lone pairs. So the valence electron for iodine is 7, and since iodine has gained 1 electron, it is 8 around this central iodine. So 8 electrons are drawn here. Okay, now this is the I3 minus ion. Now here option A says that the central atom has 3 lone pairs around it. Yeah, that is correct. It has 3 lone pairs, and all the lone pair occupy the equatorial position. So the horizontal positions are called as equatorial position. Yeah, all the lone pairs are occupying the equatorial position. The III bond angle is equal to 180 degree. That is also correct. If you see the bond angle here, it is 180 degree only. Okay. So there are 2 iodine atoms around the central iodine atom that occupy the equatorial position. No, the 2 iodine atoms are occupying the axial position. Right, they are occupying the vertical position, which is called as axial position. So option D is the incorrect statement for I3 minus I0. Okay. Now moving on to question number 47. In which of the following compounds does sulfur obey the octet rule? So let me give the structure. For option A, S sub 6. So sulfur is bonded with 6 fluorine and it has 6 bonds around it. Each bond contains 2 electrons. So 6 into 2, it will be 12 electrons around the sulfur. Okay. Now coming to option B. Sulfur is bonded with 2 chlorine and sulfur valence electron is 6 and 2 has gone for bonding and the remaining 2 will be present as 2 lone pair. Now here around each the sulfur we have 6, 1, 2, 3, 4, 5, 6, 7, 8 electrons, right? Yeah. So 2 bonds and 2 lone pair of electrons. So it will be 8 electrons around this sulfur. 8 electrons. So SCl2 molecule only obeys octet because if a compound has to obey octet rule, it should contain 8 electrons around it. So SCl2 molecule is having that. So option B will be the correct answer. And coming to option C, it is H2SO4, H2SO4. So in H2SO4 also if you see, so there are 6 bonds around sulfur. So 6 into 2 will become 12 electrons. Okay. And in case of SO3, it is trigonal planar in geometry. And here also 6 bond around sulfur, 12 electron. So in option A, C and D, sulfur is having 12 electrons around it. Means it is having the expanded octet in those 3 cases. Whereas in case of SCl2, it is having 8 electrons around it, in which it obeys the octet rule. Got it? So option B is the correct answer for this question. Now coming to the next question. A monoatomic ideal gas undergoes a process in which the ratio of pressure to volume at any instant is constant and equal to 1. If the molar heat capacity, that is R into K, is this, and then find the value of K. What we have to do, what is given? So the ratio of P to V is given. So pressure to volume ratio is constant and it is equal to 1. Okay. And we have to find out the molar heat capacity and it is given as R into K and we are asked to find out the value of K. So let me take the relation equation for molar heat capacity. So the molar heat capacity, that is, which is represented as C, that is equal to, for monoatomic ideal gas, it is Cv plus R divided by 1 minus gamma. Okay. So when pressure volume power gamma is equal to constant, and here Cp by Cv will be equal to gamma, and it is given P by V is equal to 1. So this relation represents, that is, this relation represents Pv power minus 1 is equal to constant. Okay, so it is equal to constant. So just substitute here. So the molar heat capacity becomes C is equal to, for monoatomic ideal gas, Cv value will be equal to 3 by 2R. So substitute 3 by 2R in place of Cv for molar heat capacity plus R divided by 1 minus. So the gamma value is minus 1. So substitute minus 1 in place of gamma value and we will have 3 by 2R plus R by 1 plus 1, so it will be 2. Now here it is 4 by 2R, which is equal to 2R. Okay. Now this 2 is the value of K. Okay. 2 is the value of K. Value of K is 2. So that is the answer for this question. Got it? Now moving on to the next question. A certain mass of gas is expanded from 1 liter 10 atmospheric pressure to 4 liter 5 atmospheric pressure against constant external pressure of 1 atmospheric pressure. If the initial temperature of the gas is 300 Kelvin and the heat capacity of process is 50 joule per degree Celsius, then the enthalpy change during the process in kilojoule value is. And 1 liter atmosphere is approximately equal to 100 joule. It is given. So what we have to do, we have to find out the change in enthalpy. So we have to find out delta H. Okay, this is what we have to find out. So to find out delta H, we need delta U plus delta PV. Okay. To find out delta U, what we need? Delta U is equal to Q plus W, right? So that we need. So we know that Q is equal to C delta T and W is equal to minus P external delta V. So using these relations, we can find out delta U, and from delta U, we can find out delta H. So let me start with the thing. So there are two states given here. Okay, this is the initial state and this is the final state. Now for the state 1, for the first state, for the state 1, PV is equal to nRT from ideal gas equation, right? Now the pressure is 10 atmospheric pressure here and the volume is 1 liter, which is equal to N into the value of gas constant, that is R, when in terms of atmospheric pressure is 0.0821 and the temperature, initial temperature is 300 Kelvin. So it is 300. So the final answer for N value will be 0.4. Number of moles is 0.4. Now for state 2, for the final state, for PV is equal to nRT, pressure is given as 5 atmospheric pressure and volume is 4 and N value is 0.4, which we have calculated, and R is 0.0821. Now final temperature we don't know. Now on solving this, we will get T2 as 600 Kelvin. Okay, this is P1, B1, T1, and this is P2, V2, and T2. T2 is 600 Kelvin. Now we know that delta U is equal to Q plus W and Q is equal to C delta T plus W is minus P external delta V. Okay. Now the C value, the heat capacity is given as 550 joule. So substitute 50 in place of C and we don't know the change in temperature, that is 300 joule minus, and external pressure is given as 1 atmospheric pressure, right, in the question. So in place of P external, substitute 1 ATM and the change in volume. So the change in volume is 4 liter minus 1 liter. So it will be 3 liter. So 3 liter. So from this what we will get? We will get 50 into 300 is 15,000 minus 300. Okay. So here it is in terms of joules and here it is in terms of atmospheric pressure. So when we convert this into joule, we will get 300. Okay. That is, we have to multiply the thing into 100. So 3 into 100 will be equal to 300. So therefore, delta U is going to be equal to 14,700 joule. So this is the value of delta U. Now we can substitute this delta U in place of delta H. Okay, in the delta H equation. So delta H is going to be equal to delta U plus Yeah, it is a change, that is P2 V2 minus P1 V1, right? So delta U is 14,700 plus P2 is 5 and V2 is 4, P1 is 10 and V1 is 1. It is in terms of atmospheric liter. Okay, so this is separate. And on solving this, we will get 15,700. That is delta H is equal to 15.7 kilojoule, which is approximately equal to 16 kilojoule. So that is the value of delta H. That is the value of delta H. Okay. So this is how we are calculating. We are using these relations to find out the value of delta H for the question. Got it? I hope this is clear to all of you. Now we will move on to question number 53. If Cv is equal to A plus Bt, where A and B are the constants having value 4.0 joule per Kelvin per mole and 6.0 joule per Kelvin per mole respectively, then what will be the change in internal energy if 3 moles of an ideal gas is undergoing a transformation from 27 degrees Celsius to 127 degrees Celsius in kilojoule unit? So we have to give the answer in whole number. So it is given that Cv is equal to A plus Bt. Okay. And the value of A is 4 and the value of B is 6. Okay. Now we have to find out the change in internal energy. That is delta U we have to find. We know that delta U is equal to NCV dt. Now on integrating this equation, okay, let me just substitute the value of Cv. Integration of N into the Cv value is 4 plus 60, right? So it is 4 plus 60 into dt. The limits is RT to T1 and T2. Now delta U is equal to 3 into 4. Okay. It is 3 into 4. That is T1 is 300 Kelvin and T2 is 400 Kelvin. Because 27 degrees Celsius, when you convert it into Kelvin, you will get a 300. And for 127, it is 400 Kelvin. Okay. So it is 3. I am multiplying here by the number 3. Because the number of moles is 3. It is given in the question. The N value is going to be 3. So just integrate, do the integration for each term. That is for 4 and for the 60. So I am applying for 4 first. So it's a constant. So it is coming out. So we are left with only dt plus 3 into 6 is a constant. Take it out and apply the limits only for the t which is there. So integration of x into dx is x power n plus 1 by n plus 1, right? So here we will get t square by 2 because n value is 1. So t power 1 plus 1 is 2 by 1 plus 1 is 2. So again 2 is a constant, we can take it out. If we take this constant out, 3 into 4 here is going to be 12 and integration of dx is going to be x. So we can just substitute 400, substitute the limits. So it will be 400 minus 300, which is 100. Coming to the second term, 3 into 6 is 18 and 1 2 is there. We can take that also out and we will have, we are left with only t square. So when we apply the limits 300 and 400, if we apply, we will get 12 into 100 plus 18 by 2. So 14 square is 1600 and it is 1600 minus 300 square is 900. Okay. So let me write here. It will be equal to 12 into 100 is 1200 plus 18 by 2. 1600 minus 900 is going to be 700. Okay. So from this we will get delta U value as 7500 joule, which is equal to 7.5 kilojoule and it is approximately equated to 8 kilojoules. So this is the answer in terms of whole number. So delta U is equal to approximately equal to 8 kilojoule per mole. Okay. Just we are doing the integration here and applying the limits. So while applying the limits, first we have to apply the upper limit minus lower limit in the place of t. T is the x here. Got it? Now coming to question number 55. 1 mole of IO3 minus ions is heated with excess of I minus ions in the presence of acidic condition as per the following equation. IO3 minus plus I minus giving I2. How many moles of acidified hypo solution will be required to react completely with iodine thus produced? So we have to find out the number of moles of acidified hypo solution that is required to react with I2. So first let me take the equation. So here 2IO3 minus reacts with the 10 electrons to give I2. Okay. Now 2I minus gives I2 plus 2 electron. Okay, now if I multiply this equation by 5, I will get, if we multiply this by 5, we will get 10I minus giving 5I2 plus 10 electron, right? So now this is equation 1 and this is equation 2. Now if we add these two equations, 10 electron gets cancelled. So here in the left hand side we have 2IO3 minus, and here in the equation 2 we have 10I minus giving 5 plus 1, 6I2. Okay, this is taken as equation 1. 2 moles of IO3 reacts with 10 moles to give 6 moles. Now, since and if I simplify this equation, I will get, if I divide this equation by 2, I will get IO3 minus plus 5I minus giving 3I2. Okay, so this is the final equation. Now 1 mole of iodine, IO3 minus reacts with 5 mole of I minus to give 3 moles of iodine. Okay, now coming to the second part, that is with hyposolution. So iodine is reacting with hyposolution. Hyposolution contains S2O3 2 minus ion and it gives S4O6 2 minus ion and iodide will come out. So here I have to put 2. Okay. Now here 1 mole of iodine is reacting with 2 moles of S2O3 minus ion. Got it? Now here 1 mole of IO3 is reacting with 5 moles of I minus to give 3 moles of iodine. But here 2 moles of thiosulfate S2O3 2 minus is reacting. So it will be equal to 2 into 3 moles of iodine. 2 into 3 mole of iodine, which is equal to 6 mole of S2O3 2 minus. Okay. So 6 mole of this acidified hyposolution is required to react completely with the 3 moles of iodine. Okay. For 1 mole of iodine, 2 S2O3 2 minus is reacting. For 3 moles of iodine, 6 mole of S2O3 2 minus will react. So that is the answer. Okay. Now coming to question number 56. In neutral or faintly alkaline solution, 8 moles permanganate anion quantitatively oxidize thiosulfate anions to produce X moles of a sulfur containing product. The magnitude of X is. So the question says that permanganate ion, that is MnO4 minus, is reacting with thiosulfate ion, that is S2O3 2 minus, to give MnO2 plus SO4 2 minus. Because in alkaline solution, MnO4 in plus 7 oxidation state, it can be reduced to plus 4 only. Only in acidified solution, it can be reduced from plus 7 to plus 2. But in case of faintly alkaline solution, +7 to +4 only happens, okay, for manganese. And the oxidation state of sulfur here is +2 and here it is +6. Now if you see the change in oxidation state, manganese is going from +7 to +4, that is it is gaining 3 electrons, and here from +2 to +6 sulfur is losing 4 electrons. Okay, now the equivalence of MnO4 minus should be equal to the equivalence of SO4 2 minus. Okay, so that is what is equivalent? N number of moles into N factor. So that is the moles of MnO4 minus into N factor is equal to the moles of SO4 2 minus into N factor of this. So what is N factor? It is a valency factor, number of electrons lost or gained. So the number of moles of MnO4 minus, it is given as 8 moles. So let me substitute 8 here, and the valency factor, that is the number of electrons gained by this manganese, is 3. So NF is 3, which is equal to the number of moles of SO4 sulfate ion. That is only we have to find out. Let me take that as X, and the valency factor, number of electrons lost by the sulfur is 4. So X into 4. Okay. So the value of X will be 6. Okay. The magnitude of X is 6. Number of moles of SO4 2 minus, which contains the sulfur. So that is equal to 6. Now moving on to the next question, question number 57. The equivalent weight of phosphoric acid in the reaction. So the equivalent weight can be calculated using, it is equal to the molar weight or the molecular weight of the substance divided by the valency factor. Valency factor. Okay. Molecular weight divided by valency factor. So the molecular weight of H3PO4, it is equal to 98. Okay. Because for phosphorus, it is atomic mass is 31, and for hydrogen it is 1. We have 3 hydrogens, so 3, and for each oxygen it is 16. We have 4 oxygen, so it is 64. So when we add everything, we will get 98, right? So the molecular weight of the H3PO4 is 98. And now the change in valency, if you see, the oxidation state of phosphorus in H3PO4 is +5. And here it is +5. Here also it is +5. So just give me a second. It is sodium, so +1. For hydrogen also it is +2 plus X -8, right? So X is equal to 8 minus 3, which is going to be +5 again. Now here also the change in oxidation status, the oxidation state of phosphorus is +5. Here also it is 4 into 2, 8, 8 minus 3 is +5. So +5 to +5. So change in valency is almost equal to 1. So equivalent weight is equal to 98 by 1, which is equal to 98. So the equivalent weight of phosphoric acid is 98. Got it? Now coming to question number 58. The ratio of energies of helium plus for first and second excited state is X. Then the value of 4X will be. Yeah. So coming to the first excited state. First excited state means from first level to the second level. That is second shell. From first shell to second shell. And the second excited state means from the second shell to third shell, right? So it represents the jumping of electron from second shell to third shell. And we know that energy of any nth shell, it is directly proportional to z square and inversely proportional to n square. Okay, so E2 divided by E3, it will be equal to 4 by Z value for helium is, atomic number for helium is 2, right? It will be 4 by 4 into 9 by 4. Okay, because if we substitute for E2, it will be equal to 2 square is 4 by n value is 2, so 2 square is again 4. And for E3, it will be, atomic number is going to be same, so it is 4 divided by, but n square will be 3 square, right? So it is 9. Now when we take the ratio, we will get like this. And we are getting E2 by E3 as 9 by 4. Got it? Now, the ratio is taken as x, then the value of 4x is. So 4x is equal to 4 into, this is the x value. So 4 into 9 by 4. So 4x is equal to 9 and x is equal to 9. Four x is equal to 9. The value of 4x is coming out to be 9. Okay. So coming to the question number 59. In an atom, the total number of electrons having quantum numbers n is equal to 4, ml is equal to 1 and ms is equal to minus 1 by 2. So if the n value is equal to 4, L can have values from 0 to n minus 1, right? That is 0, 1, 2 and 3. So if L is this, then ml, magnetic quantum number, it will be equal to minus L to plus L. For 0 it is 0 and here minus 1, 0 and plus 1. And for L is equal to 2, it is minus 2, minus 1, 0, plus 1 and plus 2. And here it is minus 3, minus 2, minus 1, 0, plus 1, plus 2 and plus 3. Okay. Now coming to the spin quantum number, that is ms. For ml is equal to 1. Modulus of ml is equal to 1. So if we put minus 1 inside the modulus, it is going to be plus 1. So here we have 2, 1, minus 1 plus 1. Here also we have 2 and here also we have 2. Okay. So we have 2 electrons here and minus 1 and here 2 electrons. So in the same way we have 2 electrons in all the minus 1 plus 1 orbitals of L is equal to 1, L is equal to 2 and L is equal to 3 case. So 2 electrons we have, one electron will be in plus half spin and the other one will be in minus half spin, right? So in that case, for the first orbital we have 1 minus half and for the second orbital we have 1 minus half. Here 1, here 1, here 1 and here 1. So totally we have 6 minus half spin containing system. Total number of electrons having S is equal to minus 1 by 2 for modulus of ml is equal to 1 is 6. Okay. Totally 6 electrons we have with minus half spin. Okay. Now moving on to the last question for this session. It is question number 60 and it says that the total number of protons in 10 gram of calcium carbonate is Y into Na, then Y is, where Na is the Avogadro number. Okay. So now first we have to find out the moles of calcium carbonate. Number of moles is equal to the given mass divided by molar mass. So the given mass of calcium carbonate is 10 and the molar mass of calcium carbonate is 100. Okay. For carbon it is 12 and for 3 oxygen with 16 each and for calcium it is 40. So when we substitute everything we will get 100 as the molar mass of CaCO3 and it is equal to 0.1 mole. Okay. Now the number of the number of proton in one molecule of this CaCO3. Number of proton is nothing but the atomic number, right? The atomic number for calcium is 20 and for carbon it is 6. And we have 3 oxygen. One oxygen has 8 electrons or 8 protons, we can say. We have 3 oxygen, so 8 into 3. So it is equal to 50. Number of proton in one molecule of CaCO3 is 50. Now we have to find out the number of proton in 0.1 mole of the substance. It is equal to 5 mole is equal to 5 mole into Avogadro number. Okay. 0.1 into 50, it is going to be equal to 5 mole into Avogadro number, where the value of Y is 5. It's very easy, right? So we are finding out the number of proton for one molecule, and from that we are getting for 0.1 mole of the substance. Got it? Yeah, I hope this session is very useful and clear to all of you. So we'll meet in the next session. Thank you so much for listening this lecture. Thank you. Bye bye. Take care.